Good morning, everyone. Good morning to all lecturers and all students of Department of Civil Engineering, Imjai University. Thank you so much for being here. Let me begin by giving you a warm welcome to join this guest lecture. Today we have a special guest, Associate Professor Dr. Thanongsak Imjai from School of Engineering and Technology, Walailak University. We will discuss about structural and engineering research, current and future challenges. For your information, I met him last year in Thailand. We were joining recycle aggregate concrete workshop. So since then, we have discussed many projects, I hope. So please welcome Associate Professor Dr. Thanongsak Imjai and have your lecture with us today.
Okay, thank you. Can you hear my voice clearly?
Yes.
First of all, I would like apologize that the internet here is not really good. Currently, I am a visiting professor in IIT Indo, India, for 6 months, and the time here is 11:15, so probably 1.5 hour time difference. That's why I would like to request the committee just make it a bit late. Otherwise, I have to wake up really early in the morning, and probably some of you disappear during my presentation. Anyway, Assalamualaikum. Good morning from here, and I thank my friend Eva Alifi, moderator, Hedens, Professor Bentia, Professor Bayu Arianto, and especially the head of the department, Professor Eko Andy Soyo from Brawijaya University, Indonesia. Well, this is a good opportunity to be here and to show you all my research work, which is based on my working experience and also my research experience in both the professional career and academic sides. So I'm a structural guy, basically. So today, that's why I'm trying to focusing on the research on the structural side. So let me share your screen. Okay. I think due to the internet issues, let me try the PowerPoint first, if possible. Can you see my PowerPoint?
Yes, we can.
I'm trying to make it full screen, but the thing is the Zoom toolbars. Okay, here. Okay. Right there. I need to put the Zoom somewhere there. Okay. I hope you can see. Yeah, perfect. Right. Today, this is the first time that I present as the guest speaker or even keynote for almost 3 hours. So we normally do like 1 hour up to 1.5 hours, but I try to split. It's not working. I try to split this presentation into 3 parts. Which first, the dealing with the structural engineering research. And the second, I will show you the example of the research work that come from my undergraduate students and also postgraduate students. And the last part, I will show you probably the research proposal could come from the academics service or case study as well. First of all, I would like to show you the business of the Walailak University. I think I'm not sure some of you might visit us in the south part of Thailand. We are at Nakhon Si Thammarat province, which is down south of Thailand. So if you go from Bangkok to Nakhon Si Thammarat province, you will take probably 1 hour by flight. This is the our campus inside. We have a really huge garden. Well, our campus probably is the biggest. It's the biggest single campus in Thailand now. We also have zoo, we have the camping area, we have skywalk there, which I decided there. And we have, this is the hospitals as well. Yeah. And we have the standard, the sport complex as well. And currently we have probably 70 international students, both exchange program and also full-time students. And yeah, we are working pretty well. I also involved for the university rankings for both time higher education and QS. So we are ranked the third in Thailand now. Right, where our university is here, you can see there, the red that's not there. From Bangkok, it's probably 1 hour, I said before. So we are on the east side, the Gulf of Thailand here. Right, it's about me. Just now, Helen just give not really brief, but really long introduction of myself. But in fact, it's out of date. You can easily, right now, you can search my publication, my expert through the research gauge and Google Scholar. It's really easy. If you want to know this person, just put their name and you know what's the key activity those guys working on. Right. I did my PhD in Sheffield University in UK under the school scholarship, which means that when I come back to Thailand, I've got no place to work, meaning I'm a free man. So I can go anywhere. Right. And then after that, I don't want to come back to Thailand because I enjoy the British cold weather. So I continue to work at a postdoc for 2 years. And then I'm not sure whether it's bad or good opportunity. In Thailand, when you go up at some point, you need to make a draw. Yeah, to make a draw to be to join the army. So there's a black sticker and red sticker. So if you get the red sticker, then you join the army. So there will be 100 people in my village and only 30 that they need to go to the soldier. So probably I was lucky. I got the red, and then I joined army for 1 year. But remember, I already hold the PhD certificate that time. So the life in the army is really tough and something that you have to go back probably 100 years ago. Yeah, I don't want to talk about it, but really nice experience. That's why I don't think that any social difficulty for me anymore. Nothing tougher than the life in the army. Yeah, and then after the army, I worked as the structural engineer for 5 years. That I will tell you the reason why later. And then after 5 years and another 3 years as the part-time structural engineer, I joined academic life. So in 2015 that I worked in Bangkok, and then when the PM 2.5 came, I don't like to work in Bangkok anymore due to traffic problems. I have to leave my home probably 2 hours to workplace and then come back another 2 hours. So I spent almost 4 hours traveling. That's why I decided to join Walailak University in 2019. Okay, here I choose to join Walailak University on the 1st of February because it's easy to remember, because this one is my birthday. So I try to make things easier, less complicated. They are linked to my thing that I can remember. And then I plan my career path precisely. As you can see there, after I joined Walailak University, I got the assistant professor. And after that 2 years, which is minimum that you can apply for, I've got associate professor. And then another minimum 2 years, I already applied for the full professor in this November. So I think this is my career path. I also work as the principal investigator over, I think now 30 projects, and also co-PI for 2 projects, both national and international fundings. And currently, I just checked last night, I've got 48 papers in Scopus, including the conferences, and this citation, Hedex 10. Yeah, and I also have experience as a reviewer over 30 journals. And currently, I'm in India now, visiting with professor at IIT Indo. This is the top 3 in India. So the first one probably IIT Delhi. In Thailand here, at the last point there, we have three different level of the engineering. So for example, if you graduate it, you get the level 1, we call graduate engineer. You need to pass the exam. And after that, you need 5-year experience to be able to apply and test to pass the test. We call level 2, probably professional engineer. But you need a good experience of design work to get the second levels. You can see there, if I jump from the army life or soldier to the academic life directly, I will not have any experience or any opportunity to work as an engineer. So there's no way that I can apply as professional engineer. When you get professional engineer, you need another 5 years to apply senior professional engineer. The senior professional engineer probably we have this is the 3rd level. This is really rare. Normally, this one they will give you probably the age of 50 or 60. They will not give easily, let's say, because the senior professional engineer, they can do everything, including the consultancy work, especially strengthening, rehabilitation, and when your building have problems, only the senior professional engineer can design and consult work. But I'm not sure the system in Indonesia. I think in US probably the same. In UK they call senior charter professional engineer. So this is the why I need to work. I plan myself to work in the industry as the structural engineer first to gain experience, and I have improved my CV in order to apply for the senior professional engineer before I enter the academic life. Right. Well, this is my team. Okay, we have even though our university is really big, but our faculty member, especially in the civil engineering, not many. We have only 10 people, full-time staff there. These 3 here, we are working on the structural research. We have about 120 students each year, so we are recruiting a new staff member every year. But we pay really well, but the condition really tough. I think you will know that because we are required to publish 1 Q1 paper per year. So if you can't do it 2 years continually, you will fire. So this is quite challenging for lecturer here. And I also have 3 PhD students. The guy from Iran holding durian there, 1 guy from Ethiopia, and 1 guy from Nepal. Okay, this guy from Nepal, he's the head of the department. He came here to pursue a PhD, and I have 2 master students. All right, the content here, as I already said, I'm going to split into 3 parts. Because if I continue talking for almost 3 hours, I think some of you might switch off, turn off the camera and run away. So let's make it the first one, structural engineering research and motivations. What is it about? I'm going to show you the current and future challenges and motivation. Why you need to do this? I hope that I think some of you already got the research or final year projects, because as far as I know, participant here, the 3rd year up, and also include the final year and MSc student and PhD student as well as the lecturer and faculty member. And the part 2, I'm going to show you the example. This is some of the example of the structural engineering research. from my undergrad and postgraduate students. And later, we also can use the practical cases and case study for the projects. And we can publish this as a case study as well. This in part 3 here is come from the real engineering problem from the industry, from the owner that come to ask your advisor, ask your supervisor, and then you can join them, then do some design work. Right, this is part 1. Okay, after part 1, we will have a few questions that you can interact with me, ask me, and then we can discuss. Structural engineering research. In this part here, you should be able to understand the problem statement and motivation. The motivation could come from yourself, and also from your own interest, and probably from the future trend. And you should understand the research methodology. I think this one you can learn probably I'm not sure for the undergraduate, but for the postgraduate, you should learn the research methodology for civil engineering. Through working on this part 1 here, you should develop your own skills enhancement program, which include many different skills. I mean soft skill, for example, leadership development, mentorship, coaching, team management, time management. This thing will improve you and before you go to enter the real world. The real world means after you graduate, you need to work on your own and work as a team as well. Right. I'm going to show you just one key picture here. This is the research methodology. So you can go further at the reference here. Cohen, Lewis, 1989, research method in education. So all of the research area pretty much the same. You define your research problems, and then this research problem here could come from your own interest or your advisor, or you just questioning something and you define the problem. If I do this, what happened? If I don't do this, what happened? If I do another method, what will happen? After this, you can try to find the answer by working on the literature reviews. So this is kind of another step that you want to see. You want to find out, is there any people working on this similar area or trying to answer your research problems? And after that, you can also start to formulate the hypothesis. If I do this, the answer could be this. If I do this solution could be better than the one that exists, something like that. And then you decide to test your hypothesis. For example, if I want to repair the column using the conventional method, it can increase the capacity up to 10%, let's say. But let's try something different. If I add this, if I use different materials, then it could even better, could increase up to 50%, but the cost is cheaper. This is the way that you try to plan your methodologies. And then feed forward, F it means feedback to C. So this kind of, when you do some tests or planning the test, you can also collecting data, execution, and work in the lab, work in the field, and then do some analysis. And to come back to your initial hypothesis, whether that you think is correct or not. If you do this, it increase 10%. If you do this, it increase 10%. If it follow your initial hypothesis, then it's okay. If not, and why not? Yeah, and then it could come back and retest it again. So when you do some testing in the lab, it doesn't matter if the test it failed. It's not really follow your first hypothesis. It could be like this, but it could be different. So this thing you need to discuss with your advisor. And after that, you can do the interpret and report. So it's kind of the process going on here. Okay. Right. This is another key, the clear picture. Do you know what is different between projects between undergraduate, master student, and PhD and postdoc? Let's say this circle here is the knowledge of current situation or current time. So you study whatever it is, let's say coursework, and you know all that you want to know, and this is the knowledge there. And then you expand a little bit. For example, for master students, for MSc students, then you study a little bit more, which means the coursework that you did not study during your undergraduate. It means you expand your knowledge via the coursework. And then this is PhD or Doctor of Engineering. The orange circle, this is the current knowledge, okay, that you should know. And then when you do PhD, the red circle here is the boundary of the current knowledge that I said before. And when you do the PhD thing, you need to expand knowledge there more than the current knowledge at your times. That we call novelty. Okay, that we are calling novelty. So be aware that PhD student, you need to push novelty beyond the current knowledge. Yeah, but for master student, for undergraduate student, you are still okay with this circle there. But if you can do it like push another thing new, propose something new, that it will be really good. And also when we are working as the structural engineering research, 3 things I would like to remind you to remember. The blue one, experimental or program or laboratory work, meaning that you can test this thing in the lab or even in the field test. Okay. So, and another one, the red one, you have equation, you have analytical study, theory comparison, and the code comparison as well. And this is the purple one, you do some computer simulation, modeling, finite elements, and then you can propose new equation and new theory. The thing is, if you're working at the UG students, you can work on your final year projects, one of these. You can choose according to your own interest, according to your advisor, could be one of these, or combination. For example, you can do only experiment and report. But some of you, I don't like to cast concrete. I like computer simulation. Then do computer simulation only and use the previous test results from other and compare. But some of you, I love to write my own code using MATLAB, let's say, using Python, using C++. Okay, then write your analytical study, compare the different equation and say which one is better, which one is not, which one can cope better. And then to do the red one here, you need good knowledge of statistics comparison. For example, R-square values, something like that. You need this. And when you move to master levels, for example, MSc, I would say you need at least 2 of these 3. Yeah, it can be either experiment, analyticals, experimentals study, and finite element study. But if you can do 3, that is the best. Okay. And now when you move to PhD levels, I would say that the combination of these 3 will be great, and it can answer almost everything. But some PhD work can also rely on only 1 or 2 of these, but that need to be really distinguished result and outcome. For my work, when I did my PhD, I have both this experiment analytical and also finite element analysis as well. So I can combine these three, and I had experience of working these three part with it linked together at some point. So think about it. Your current projects dealing with what? Experimental study only, or you have experimental study and you have analytical as well, or I have only computer simulation only. So think about this. And you know what? When you're going to the job interview, they're gonna ask you, what is about your final year projects about? If you have experiment, if you have computer simulation, I think they will be really happy. But if you do only experiment without doing any simulation, then they're gonna ask you more. Okay, so think about this. Right. Before this, can you answer these questions? And again here, if some of you already have your own projects, and some of you are in the third year undergraduate, probably you are going to select one. So think about this, and ask yourself, what are your research variables? The variable can be primary, secondary, control, and independence. And what are your research hypotheses? And do you have keywords or not? This is the key question that I normally ask when I have been invited at the exam panels. PhD, MSc, I ask the candidate first. If they can't answer this, then they probably high chance to fail. Okay, you need to be able to answer this first, right away from your own mouth, I would say. And then, what are the key paper, key mans in your research topics and what year? You need to define immediately what the key paper. Normally for my PhD work, I collect up to probably 300 papers. And after that, you read through and you condense them, probably up to 5 to 10 key papers. Okay, so this is another question I'm gonna ask when I am at a judge panel during the PhD interview or MSc interview. What is the key man in your research area? What is the key paper and which year? So you need to understand this and answer this right away. Okay. Last, what will be your output and outcome? The question is, if I ask you, who care about your work? I don't care, but who care? Why you need to do this? Is it rubbish? Nobody do this. Why? But many people have done it before. But why you have to do it again? Why? So the last question will define your novelty. Okay? So this thing, you need to refer stakeholders, for example, end user, engineer, academics, for example, and also number of applications that can be output, but not outcome. Okay, I published this in the Scopus Index papers, 2 papers, okay, the output, and then the outcome, what is that? The outcome means you're trying to change something in terms of economics, policy, social welfare, for example, and academics novelty. This is you trying to contribute or change something that could be better compared to the previous one. And then another one, you trying to answer the problem from industries, or the output from this work. I also have one intellectual property. For example, you file with the patent, for example. Okay, I will say that these 3 are the key issues that you need to keep in your mind. Okay, and I would say that when you have the exam, you shouldn't be able to answer this right away. meaning you need to prepare in advance. Come back first. The last one, what will be your output outcome? It doesn't mean you need to answer, or it doesn't mean you have to have everything of this. You couldn't be have only one. For example, one publication, fine. If you can't publish, fine, but you can refer, okay, my work can solve the problem of who. This, for example, or my work got one patent. That's really good. You can have all of these or just one of these, but you should have at least one to answer the output and the outcome. Another one, if you study even further, you need to show your impact. But the impact, it will not happen suddenly. The impact will have short-term impact. That means after your work 1 year, it meaning somebody need to use your work, somebody need to apply your work, and then that will impact something. So that's why we have long-term impact. Let's say 5 years, 10 years, what will happen from your work? That's why I just showing you here, output only. Output is right away after you're finished, and outcome probably right away and maybe after your work finished 1 or 2 years. But the impact could become probably 3 or 5 years or 10 years after your work have done. Right. Sorry, it's bit in Thai, but here, but I can put well, you can see, you can read in English here. This is the current and future challenges in structural engineering research. From my own experience, from working in the professionals engineers, and also interact with many professors in structural engineer. So I divided the topics of structural engineering research into 6 main categories. Could be more, could be less, but in my own choice, I'm working on these 6 categories. The first one, concrete structure and technologies. Concrete structure and technologies, I named this because we have technology, meaning the concrete changing time to times. Fiber, reinforced concrete there, meaning you have concrete, you want to improve the property to suit your choice of application. And we have seismic strengthening and rehabilitation or strengthening here. Advanced composite in constructions, recycled material in concrete, and the last one, structural health monitoring and assessment. Number 6 here, it comes from my own experience and my own habit. I like this one. Number 6 is like you act as a doctor, and when you have patient come, you have to check and give them a medicine, the right medicine. It's the same thing. You are a structural engineer, and you need to go out and check your, well, all buildings and see what happened this, and you need to propose the right solution. So number 6 here is going to come from the real case study and practicals, okay? And you know what, when you go to the Scholar, Google Scopus, if you select the categories, they will have only 2, I think, the main category, building and construction. And another one, I think, structural, civil and structural engineer. So this one, in this 6, I can put in both 2, okay? I'm not going to crazy publish everything of the world, meaning you are not really expert in any field. You just publish a lot, and you need to do a lot of things, but you need to narrow and really expert in one field. Okay, that's important things. Okay, and let me go more. I need to hide this one. So I can hide this. Can I try to hide this thing here? No. Okay, anyway. Right. This one, I'm going to show you this later, part 2. Yeah. Concrete structure and technology. As you can see here, we have full scale house as well. This is about the improve the concrete property and use it as the thermal insulation panel. So this is kind of one of the topic that my undergraduate student work on it, and this project finished already. And you can see there, this is the wall panels. We have cement board, we have foam grade, which is fireproof as well, and we have pier foam concrete there. And my hypothesis is it possible if we make the wall panels really thin, having really good thermal resistance, and also can act as a load bearing wall? When I went to a market one day, I saw this waffles. Then I think, oh, it's possible to make it like this. Of course, we can make it solid, but it will increase the dead weight, the dead load. So I make it, and I combine the EPA foam to increase both acoustics resistance and thermal resistance. Because in Thailand, of course, we not really the weather not really cold, but it's really hot. So if we couldn't do this, we could save our AC, the air condition, the air and electrics during the daytime, at nighttime as well. And then I design this according to the thickness of the window and door frames. So the thickness is about 10, the standard size. And you can see there, this is the prototype. For this one, I will show you later in part 2, okay? Another one that I'm working on is about pavements. The pavement is possible that during the rainy season, it's possible to get the drain through the pavement we call pervious concrete or porous asphaltic concrete. So I worked it with the Department of Highway, so we can have the really nice full scale test. Okay, this is the construction of full scale test. It's about, I think the distance of this test section is about 400 meters in Bangkok. So we keep monitoring. We have been monitoring over 5 years, and now it's still under operate and monitoring the performance as well. Another thing I'm going to show you. This is still work. I've got the requirements and problem from the industry. They want to increase the space during the construction. As you can see here, yeah, as you can see there, this is conventionals. We have precast slab sitting on the steel beam, and here we have the inverse T-beam, and we have the precast unit slab there. So this choice is not really good. For example, if you want to build the car park, you need to reduce this space, the vertical one. So it's possible to combine the section embedded inside the girder or beams. So we call this system is a slim beams or slim slab system. And yeah, we got the really good company supply us with the testing beams like this. So we did the testing. Remember, this full scale, 6 meters long, and I also do some structural computer optimization to select the thickness, the length, the height, okay, according to the required live load. Second here, fiber reinforced concrete. Of course, we know that I need to delete this first. Clear. Yeah. Okay. Fiber reinforced concrete. Of course, we know that the concrete is really good when you apply the axials or in compression, but it's not really good in tension. So we can add some materials or reinforcing material to improve property. For example, we can add fiber to concrete to improve fracture property, tensile property. For example, the fiber here, we have the glass fiber, we have natural fiber, synthetic fiber, and also we have steel fiber. And sometimes you also need really flexible concrete. You can add rubber, tie rubber in the concrete itself. Then you can design when after you improve some engineering material, which application is suitable for this. Okay. Thus, seismic strengthening and rehabilitation. I also work as the strengthening and systems. This is my main research using the composite materials in concrete structure. So when in Thailand, especially from the north, we have mediums earthquake. So in the past, when people build their own house or infrastructure, since it in really countryside, they mix concrete by themselves. So the quality is not really good. So we did not expect the earthquake happens, but in the last 5 years, we have a very strong earthquake in the north of Thailand, Chiang Rai province, if you heard about it. So I went there as the structural engineer, and then it's impossible to remove all houses or buildings away and rebuild it and according to the new code. So we need to do some strengthenings. So there are various choice of strengthening. Mainly, you trying to improve both ductility, deformability, and also capacity. Sometimes you can't improve much capacity, but you can improve ductility. So there are various choices of strengthening materials. For example, very high ductile steel plate, FRP, for example. I'm going to show you this also later in part 2. Okay. This is our facilities. Okay, we have the we can also test the cyclic behavior of the substandard moments resistant reinforced concrete frame. Here we go. This in our lab. Here we have 2 actuators. The big one can go up to 25 tons, and the push and pull the distance up to 1 meter. The smaller one can go. The capacity can go up to 16 tons. Okay, and also the push and pull distance is about 1 meter. So this one we are simulate the seismic force laterally, and we can build full scale. For example, beam column joist here. Both advanced composite in construction. This one, that's my one of my key research as well, because I did my PhD in this. The use of cement in concrete structure. This is my PhD titles, and you can see there, it's possible to completely replace the steel reinforcement with the FRP reinforcement. To do that, you need to understand the behavior, the design concept first, and you also need to understand this kind of issue. For example, bond interaction between FRP and concrete, and serviceability, prediction, crack width, deflection, and as well as a ultimate capacity, shear capacity, moment capacity, axial capacity, and torsional capacity. So we did different kind of tests: axial test, shear test, bending test, punching shear test, and all of that we need to do the computer simulation to predict and to validate our results. So I'm going to show you a quick example. This is another innovative active confinement. For example, if you have your own hand, you put the paper around your own hand, okay? You don't feel anything until you make your hand bigger. Then the paper around your hand start to work, start to stretch. But that we call passive confinement. But if you use rubber band to tie up your hand, you don't need to make your hand bigger, but the rubber is already working. So we call active confinement. This technique is really powerful when you do with the columns, because you want to increase the axial capacity, you want to increase the ductility. So this is the one that I invented, and also can apply to beam. You can see here the black metal strap here. The thickness only 1 mil, so you can increase the shear, the moment capacity up to, well, it depends on your design. For example, if this one you put a lot of reinforcement here, it could be over reinforced. It will crush here at failure. But if you prevent the concrete not allowing to crush during the failure, so you could increase this one up to 30 or 50%. Okay. And this is the experimental workshop during the undergraduate second year modules, civil engineering material testings. So we doing a test, and we are putting some strain gauges there to see the real behavior. And I also in each group of the undergraduates have to present the work, which means interpreted result to me, so that they can understand right from the plannings, they study, work in the lab, testing, and analysis of result, and finally presenting their results. And you can see, I think this video there, you can see there. Let me see, let me show you this first. I think, yeah. This is unstrengthening. So imagine this is the column under the axial compression. It will crack like this. But what if we confine like this? This one, the capacity increased probably 5%, if I remember. Let's try to put more belt. The belt make of the steel. Okay. This one, I think the axial capacity increased probably, I would say, I think about 25. To see the last one. This one increased 50%, which is a lot. So I would say that if you have a column and you want to increase the axial capacity, this is another choice or another way of the strengthening solution. And this, but remember, this is just a column, 30% height. What if we extend it to the real structure? I will show you. Yeah. Stop it first. Right. This is my PhD student work. So we try to extend it to the longer column, medium scale. So this project is active confinement of low strength reinforced concrete column using high ductile metal straps. Why I use low strength concrete? Because this will answer the community in the countryside area. In the countryside area, you can't have the ready-mix concrete, which is really good quality, but they mix themselves. So the concrete will very low strength. Could we go up to 15 to 19 MPa only? So we are trying to attribute the moment and axial interaction diagram. We have the axial load there, and we have the E value, electricity there. So when we applied it, we have both moment and axial combined. And when you move P here to the center point, you have purely axial load. And then we also do the pure tension like this. So combine this one, you can develop your own PM diagram of these confined columns. Okay. And this is another one. We apply this in the reinforced concrete beam subjected to pure torsion. And you can see there we have beam 1, and which is unstrengthening 1, and then for beam 2 we design the extra transverse reinforcement to cope with the torsion force, and then we use the metal strap around to see if possible to improve the torsional resistance. And here, this is the test that we did. Okay, this beam here is a bit S-shaped, let's say, or Z-shaped, and then we wrap around, and then we apply the cross beam like this, so that this beam, okay, it was subjected to pure torsion. And this one is I can't show you much the result because the manuscript is now under review in the engineering structures, and hopefully we get the good result from the reviewer soon. So this is the test. Well, yeah, I think I got some video there as well. I can show you. But normally, when students work in the lab, I also ask them to record with the video. I think that both with combining video and photo or picture is the best way. When you have the video, you remember what's going on in the lab. So you need the lab work or lab sheet or lab book. You need the video, and also you need the photograph, of course. So see this. This is time lab. And you see this one, it happened very nicely as expected. And then we also capture the crack pattern, the crack width. And you know what? In this day, when you submit the manuscript to the journals or even conference, you can put this in YouTube's and then put the links in the appendix. The reviewer, they like it to see these things. So for the last one, you can't see much crack, right? Because this zone here had been confined using the metal strap, okay? And later we cut off the metal strap, and then we compare the crack pattern with the finite element models, okay? I use GoPro to set up, and then so that they can show this to the, well, for example, to the reviewer, to the conference, and then to get the audience visually. And also remember that maybe you like to wear slipper, maybe you want to wear short, but in reality, just spend some time trying to wear nicely in the lab, because you need this kind of photo when you put in the publication. So if you wear very short and if you wear very slipper like this, there could be an issue. The reviewer may ask you to remove. So just try to make nice photo, maybe just one, and then okay, you can even wear no clothes if you like, but try to get one of this first. Okay, think about it first, because sometimes you can't reverse back the time and water. So just try to make this. Is I said, if you want to work with me, you go and buy the shirt, the doctor shirt like this. I want it. This is UK standard. You go and buy it. If not, change advisor. But this is the way that we work, and I know exactly that this photo can be put in the manuscript in our journals, but not short. Okay. And normally when I also ask them to wear the a glass, just full PPE, personal protection equipment. Yeah. Another time lapse. Maybe this can be the idea for your test setup, for your beam, for your slab. Time lapse can save time and can show everything. And also time lapse or slow motion. Okay, this is another thing that you should learn the skill. This test take about half hour, because we are doing very slow test. But I don't want to show you half hour, so we do the time lapse test. You see, and you even compare this later with the graph. Yeah, load deflection curve there. When the load go to this level, what deflection? So it's kind of combination of the IT skill, presentation skill, that will make your audience really impressive. And again, if I tell my student, if you can't do this, really easy, change advisor. Not up to my standard. It means go away. Yeah, I don't want my name to be with you. So it's no choice. You need to learn how to make the video editor. You need to learn how to do this. There are many courses freely available in YouTube. I want it because now things changing. And this one, we use both GoPro and just personal camera. But remember, you need the tripod to, don't move your camera around. You need to set up a standstill tripod. Remember this. Yeah. Okay, and this is number 5. Recycles material in concrete. The reason here, I know Eva, because I work on this topic as well. It's not really my expertise, but I need to work it. Why? Because working as the researcher, you need to apply for funding. And the government crazy about this. They want to see people to use waste material and then utilize them. Okay, if you want to do that, I can do it. But again, I'm a structural guy. I'm not chemical guy. So I don't care about chemical, but I'm thinking about end user. You have waste material, it's possible to put this end material and reuse as the structural element. That's what my work. For example, here there we have many huge amount of the old tires before we dump in the landfill. So it's possible to put in concrete, and then we can see the behavior, for example, stress strain curve, and then we can decide what application this we call rubberized concrete can be. Okay, so we need very highly deformable of concrete. Can you think about it? For example, load barrier, right? Because you need something that's soft to absorb energy. If you drive very fast, if you hit the rigid object, either your car or yourself could be destroyed. But if you hit something soft, then the energy being dissipated to that soft energy, softer. So this one being used at the load barrier, the load curve, and also the lamp. You know, when you go to the concretion road area, they have lamp like turtles. So we can use this, okay? But you're not going to use it for your column for your house. So it kind of application that you want to use. We build the very highly flexible concrete here, and you can use as a chair and can bend, you know, can bend a little bit. I will show you, later. I make the very thin bench. It can be bent, but it still stand there. Okay. Another thing is I also use improve the concrete materials by adding we call phase change material. I'm not sure whether you come across phase change material or not, but the phase change material meaning when it heat, it melt. Think about the candle. The candle is kind of phase change materials. So if you put the right amount of the phase change material, for example, candles powder in concrete, and you use as the plaster, you know that it can prevent the temperature from outside get inside up to 1 degree Celsius. 1 degree Celsius can save you a lot of money if you are in hot country. Because I did this, I monitored it for 1 month in April. Because in April is the hottest month in Thailand. So I put the AC inside and I have electricity meter. So I continually measure and I compare the one with the conventional plaster, the one with the plaster include phase change material. The one with the phase change material can prevent the energy better and also could save you money for your electricity charge. Right, this is the recycle education. Again, I will show you this. I have it in part 2. Okay. This is the recycle educate there. I'm not going to talk much because this probably we will repeat it later. And again, here, recycle educate there. We have not really good quality. We call CD and W, construction and demolition wastes. And we have a good quality one. The good quality one, the one that they send to your lab to test because you know all the history or the make design. So this is good. And another one that the waste from the pile cut off. When you do some piling there, at some point you need to cut off the pile head, right? That is really good too, the good quality. So you can use that to make the recycled concrete aggregates in both coarse aggregate and fine aggregate. Right, this is the life cycle there. Normally we have the waste from the construction, from building, we dump and we make the lost construction. That could be another possible and widely used in Thailand before. And nowadays we're trying to crush that and into the coarse aggregate and fine aggregate and reuse it and put in the ready-mix concrete and reuse it again. Of course, maybe some property is not really good, but we need to design and we need to put the safety margin in terms of safety factor. To do that, you need to do some research. You need to do some beam test, you need to do some column test, things like that. So we call RCA, recycle concrete aggregates. Yeah. The last one, I really like very much because this one, you can earn money. Structural health monitoring and assessment. As I said, I'm a senior professional engineer. So almost every month, I've got at least 1 or 2 projects. So our university said that we have the policy, the lecturer should go out and do some consultancy work and get some students to work as a team. Yeah, and then the chart will go to the university and some will go to the team. This way, students can have money, and university get some reputation. Okay, this one here, whenever I go out to do some consultancy work, I will ask them, may I get the results and publish at the case study paper. They all have to agree, because otherwise they can't find anyone, meaning senior professional engineer, to sign. So one condition, I need to write it at the case study. They say, okay. So that's why if you search my publication there, you will see many of the case study that come from the real work. Okay. Again, go into the real work, you can't wear student uniform. Okay, I bought it. This is UK standard. You can see there. It will be this photo will be very nice when appearing in both the presentation slides or in the articles. Yeah. So we have different kind of tests. We have NDT test. You may come across before, non-destructive testings, and we have the really nice logging data. This one I designed the slab strengthenings, and I also do some for loading tests. Okay. And this is my student, so that they can earn a lot of money. Nearly last of the part one now. Before we have having a break, I'm going to just give you a little bit tips, technologies, aids, and tools, just to help you make your life easier and make your life look better, more professional. This one I show to my student, and I said, you need to do this. If you don't do this, you change advisor. And I don't care, because I know that if you do this, you will have a strong background. And then when you go out to work as an engineer or even study in higher education, postgraduate, you can survive. Artwork, photo, figures, video, process data, text, and IMS, reference management systems, code check, Turnitin, Grammarly, and right now, I think some of you may come across or even using ChatGPT. Okay, this is the quality that they want to see. Some of you may like it to draw, but the thing is, can you draw it using Word or PowerPoint? Maybe you can do it, but take time. So normally, and also here, so in artwork, I recommend some vector-based program. For example, Illustrator or CorelDRAW. I personally use CorelDRAW. Okay, then I can do everything in CorelDRAW. And this is the one of the photo from my own paper, published in Engineering Structures. I show the test setup and including every detail. So when the reader see, they understand just one figure enough. They see everything, cross sections, location of the sensors, dimensions, and everything. Yeah, and you see this graph. I think it's almost impossible to use Excel. Maybe possible, but this one I use Sigma plot and CorelDRAW. Okay. Photo, figures. You need to understand to take the professional photo. Okay. You need to set up your tripod and make the balance in the middle, and put some sign saying the test by whom, the date, and your university. And when the reader see this, it means you are very careful of everything, just not playing around and get lazy. Okay, when you take the same photo, the same beam, the photo and the location of the camera should be in the same point, in the same position. And this one, you also have to get the right of the close-up view and overall view. Then the reader will understand, they can see the whole thing. Close-up view and overall view. But don't play around with the camera. Don't turn and smile. We not like that in the academic way. That is for your own selfie. Okay. Normally, you don't take photo with really clear image of the people inside because of the ethics issues. The editor or reviewer may ask you the ethics, whether you have right to show those guy faces or not. Unless it's your own face, then you have to say it. Okay, this is another close-up photo there. Drawings. Yeah, drawings. Yeah. 3D drawing. Now you have many choices to draw this. You can even do in AutoCAD, in SketchUp, in Rhino. There are many choices. Yeah. I don't care whatever you use, but I know what I want like this. You can use any program. You even can use Word if you want to draw this one. Yeah. So we care about the output, the final output, how it look like. And also the final output should contain all important information. When people read to see your photo, they need to understand completely. Process data, graph tables. Of course, we all know Excel, but I do recommend you use Excel for data analysis only and some plot for initial look. And after that, when you got the final looks, final already, you can create really professional graph using both. I recommend this one, 3. I use 3 of these. MATLAB is good, but it takes time. It's really huge programs. I normally use Sigma plot. It's fast and really easy to use. Origin is good too. You can use it. All of them can use and analyze some statistics analysis as well. Personally, I do recommend Sigma plot and Excel work together. Yeah. You can see this. This is process data. When you get the plot from, for example, Excel or Sigma plot, you can combine with the vector-based programs. CorelDRAW, I like it really much, or AI, Illustrator. So you can add some beam, for example, for this one here. You see, figure 6, longitudinal bar strain record during test. You can then the reader know exactly what the position in which bar according to the results. This one will build the impressive feeling of the leader, of the audience, and then reduce a chance of rejection. For example, if you submit a paper. You see this again here. Okay, another type settings. I use both. Before I use latex. Latex is, I think, if some of you may come across, it's really beautiful, especially if you have many equation or math. LaTeX is the program we call what you see is not what you get, meaning you need to write code and then compile and then regenerate really beautiful. And then Word, what you see is what you get. If you want to write equation, then write equation using probably equation manager or math type, for example. You can use both. And I use both. It depends. If I have many equations, I use LaTeX. But nowadays they have overleaf. Overleaf is really good. They can convert Word to LaTeX. Yeah. I will show you how LaTeX look like. There, if you want to write the text, you have to write like this. And then when you compile or run, it show like this. So it's really beautiful. And this one, when I see a book, I know immediately this book was like written using LaTeX or Word. Okay. So for example, the equation, you need to write like this. I think normally people from mechanical, computer science, and mathematics, they use a lot because they're dealing with many equations compared to civil. Unless you're working on the simulations or equation, then you may consider working on this. My map, I think my map is good for your own choice to help you manage time for yourself. Maybe many things around the whole day come to you, and then you can use my map to manage yourself. And I use this all the time there, and you can see there back to 2015 when I was in UK as the visiting professor. I plan myself 1, 2, 3, 4, 5. This one is one paper, and each paper we link together. Which one I should do first? For example, this myself. For example, if I have one project there, this project will be published in different in different journals, and this journal can be what? For example, this one, okay, I do in 2016, and this one I can do next, like this, for example, and I can see the whole things, and then I know which one is more. Then I put 1, 2, 3, 4 like this. Okay, this is another choice that you may consider to help you for time management. Calendars, this is important things. When you,
for the presentation, you have 90 minutes.
19.
Right. Yeah, 90.
Yeah.
90 minutes.
Yeah.
So you have around 15 minutes.
Good. And finish all, yeah? Okay. Nearly then. Personal calendar, I do recommend this because you can plan yourself as well. Yeah, and then some of you may use it already or may not, but consider, and you can track the activities. And of course, this is online free. You can then help the research paper and thesis writings. This one I also give you smart to use. This day, people tend to use the ChatGPT, and it can be very useful. For example, literature search and build up your research content. Then you can ask him to try to show you the overall content first, but be careful that there are some program, if you just copy and paste, there are some program also can check you whether you are using 100% ChatGPT or not. I would say that ChatGPT can help you to see the overall content, and then you go back and look. It's better than you start the whole thing by yourself. Okay. Last, for the part 1, I want to remove this, but I can't anyway. This is I want to show you leadership and mentoring skill. You know what? If you work in the group, how can I remove this thing here, the black one here? I want to remove this away. This one? No. Okay, anyway. This one, we call leadership mentoring skill orchestrally. You know what? When you are working as a team, there are probably 5 group of people in this habit. For example, 1-1 here. They have the questionnaire. 1-1 is mean they don't care anything. They don't care about people. They don't care about the result or the teamwork. If you have 1-1 people in your group, just use them to buy food, buy drinks at the labor. Don't let them be your leader. Then they will feel they could make your project fail. It's not their fault, but they're born to be like that. So ask them to do some cleaner work. And then if you get someone one night, it means they care for more people. They care about your feeling. They care about everything. This guy here is good to go out and buy food for you. Yeah. And you have 9-1. They care about work. They're crazy about work. This is good. They can ask him to do some of the design work, things like that. Okay, we call 9-1. And the best is 9-9. This is balance, team management. We call ideally leader skill. So they care both people and work. Okay. Sometimes we have to act 5-5 in the middle, compromise. Yeah. So this one, I would say that this is the big theory. I also written one paper on this, using grid theory for writing or research work. Because you will interact with different kind of people, then you need to put the right man in the right job. Okay. Right. I think that since I prepare really huge amount of slide, because I aware the times that you give me a lot, and this is the end of the part 1, I would say. And then part 2 and part 3, I'm not sure. Should I continue later or not? Yeah. Or this one should be the question, I think. Because in part 2, we will go deeper in detail now. Okay. Thank you.
Thank you very much, Dr. Imjai. I think we will have another session that we will discuss later about the type. Because,
yes.
Okay. So, anyone, if you have any question, you can directly mention it, and also you can write in chat column. However, if you can speak it in, I think we have one, Agung Maulana. Please, you can. I think he is from master student, right?
Yes.
Yes. Please.
So thank you, Mrs. F, for the time. So my name is Agung Maulana. I'm from a master degree in University Brawijaya. So good afternoon, Mr. Imaj and Mrs. Eva, and also all of my University Brawijaya College. Firstly, I would like to thank Prof. Imaj to provide your time and also your knowledge regarding to structural research. So I want to ask about the current and future material technologies that I'm interested in for my thesis. It's about the carrier properties of some materials that have a high porous ratio and high absorption, like a float or pumice stone, or maybe a recycled aggregate. In your research history, how to optimize these material characteristics, because we have many of it and some of it is a waste material. Thank you.
Yes, this is a good question. In fact, I want to mention this in part 2 because we have another example of the research projects, the use of recycled concrete aggregate research and Walailak University. In there, you will see many things, but I can tell you really quickly here because we optimize the different concrete strength, but now we can do up to 60 MPa. It's okay. Of course, we have very, I think, low density because of the residual mortar retained in the natural stone, let's say, and we have very high water absorptions. So we optimize by reducing water and adding the we call super pasteurizers to increase workability already. We have different type of, we can say, proportional and formula to design to achieve which strength will be required. Of course, you don't need really high strength for normal structure. You don't need it. You need normal strength concrete, probably 24, 28 is okay. And also bond is not really good. If you do some reinforced concrete structure, you need to have the perfect bond between concrete and steel, for example. And the bond, I also propose one equation for the bond reduction factor. To do that, you need to do the bond test, many bond tests, different surface finish. For example, you have round bar, you have deformed bar, and also maybe you have FRP bar. So you can have the bond reduction factor, and that bond reduction factor will go to the your equation to predict deformation. For example, deflections, crack width. So if you use the same strength concrete, yeah, one with the natural stone and one with the RCA, we have the same strength. The one with the RCA trained to have higher crack width and higher deflection. This is, we did it many times because of the bone. And also, so we propose the bone reduction factor to the deflection equation. This is another thing that we learned and we propose, even though we also propose for the shear, punching shear. If you use the ACI code, then it's trying to overestimate the capacity, even though they are exactly the same strength. So we propose probably 0.9 or 0.8. You can search my paper on, I think, building for punching shear. We put 0.85 if you have the percent of RCA less than 90%. I'm not, I think less than 85%. But if you have more than 85%, then you have to time probably 0.85. Yes. But if you have less than 75%, you time 0.9. This is example of the modification of the existing equation. Yeah. And another thing is, I think people also working on the research to remove the residual mortar, either using chemicals treatment or mechanical treatment. I'm asking you, if you ask your mom to do this, she will do or not. It's complicated, then become more expensive. And they will not do it. You can do in lab, of course, but if you want to do the house, you think you have to crush it and put in the chemical solvent and use it. I don't do it. I will go out and buy it from the natural stone then. So think about the reality, and then I will write in my introduction why we need to do this. You know, I work as an engineer. I react with the end user. They want something fast and easy to do it. If things become complicated, no, they don't do it. Yeah, I hope that this is really a brief answer, but in the next section, whenever it is, I can explain more in detail, because I start working on electrical aggregate as a structural member. And now we make the P-class unit already. I can decide, and then they like it because cheaper. I can make it cheaper. And whatever it is, I can make the strength. And my unit, my P-class unit, no steel at all, because I train it to use with the corrosion free. No corrosion issue. Yeah, something like that. So I think about the end user, think about the who stakeholder, who going to use it, and what is their feeling. I get the questionnaire. They don't want to do some complicated procedure. They just mix it and build it. That's it. Okay.
Okay, thank you for the answer, Mr. Imjai.
That's very interesting.
Some people can type, yeah, because the internet issue could be a problem, but you can type and I will read it and I answer it.
Okay. I think in the chat column, we have Agung Maulana already asking you directly. Okay, so anyone would like to ask Dr. Imjai?
I am not sure everybody here got their own project already for undergraduate. They should select the final year project, right?
Yeah, some of them already.
Yeah.
Also, I think from your presentation, I think you have many tricks for to produce excellent publication, like just about the figure and the photos. I think it's sometimes you don't consider you
No,
don't
no.
consider
The thing is, as the lecturer, as the advisor, we shouldn't look at ourselves when we were a student. At my time, my advisor, my lecturer did not tell me anything about this. Of course, I'm not really top student. I'm just middle, 5.5. Sometimes I even become 1.1. I don't care. Oh, I am tired. I just tell my friend I'm sick, but I'm lazy. I sleep in the room. You do it. But this thing here, I come back and tell my student, people was different country, different family. They have their own. So we need to see, okay, this guy like this. So, okay, you do this job. You need to see the result, the final result. You can't kill him. You can't change him sometime, but he's your friend. She's your friend. But she cannot do this. Okay, but she can buy some stuff, can clean. So think about it. Another thing is education. And then that have passion, and then want to do this. Sometimes they can't change the past. For example, they fail in RC, and then they want the master, let's say. They have very low, but I know how to make them get the really good attention from the panel by helping them to publish paper and send them to enter the competition in various events. They can't go back and restart the RC course, concrete course. That is the past, but they can do something better in the future. And then they come to me, I want to study this. My grade is very low. I said, I even lower than you when I put your time. But I will help you. If you want to do this, you change yourself, you work hard, and we publish paper together. You know that my undergraduate student publish many paper in Scopus. They have their own name there. And then when they use this, go into another university, and they showed CV. Oh, you are undergraduate, you publish. Yes, because we work as a team. And then they can go to apply for master level, even PhD level later, because they have this one. Even though the final score, the GPA is not really high. Yeah, this is another one that advisor need to help. Okay.
Okay, thank you very much. Anyone have a question? Because I have many questions actually.
The first one is really general, okay? I think people know it. I just emphasize in some important issues like that. So we need to understand, and that you develop your leadership skill. You know how to use the right man in the right job.
Yes.
Because in reality, you go out work in the company, you can't just fire your colleague. Yeah.
Yes. One question also. Actually, I also work on structural health monitoring and assessment, but sometimes you write the publication. You write for publication. However, sometimes the company doesn't want to be published.
Yes.
Especially about the condition of
some, but whatever I ask, they must obey me, because in my province, I say senior engineering, professional engineering in Thailand, probably only 200 guys.
Oh, I see.
So they come to me, they come to me, they treat me like a king. Let's say like that. Because if, for example, I will show you later why. Because there are many issues that they require the top level to sign and give them consult. Otherwise, they can't proceed. They lost money, maybe even 10 million, 20 million. That is the things. I ask, okay, I will not complain anything, but I will write it as a case study to give the knowledge to the young engineer. People, the engineer can learn at the showcase. Yeah.
Yes.
Will you accept it or not? Then I write in the contract. Then they say, okay.
Oh, you wrote it in the contract.
We have contract because this is this contract done by university and the company. So 100% go to university, and no, 15% go to university, and 85% to the team. So important thing is you don't use your own time. No, your working time from university go to do your own work. That is not really good. But I change this policy. I will use my working time work for university itself. They're using happy because they earn money. I think last year I am the most that can make university earn a lot of money. I earn probably 5 million baht. Then you can time 5 million baht time 15%. That university get it. That's why they're happy. Yeah.
Yes. Any question on this?
Please, any other ask? I'm not sure what is the plan because you tell me almost 2.5 hours and then
Actually, it's for the first lecture is 90 minutes plus 20 minutes question and answer. Then we will have another also, but we still arrange the schedule.
Okay, good. Because I gave you the all slides already. So part 2 and part 3 can be another lecture, and part 2 will go deeper on the case example of the real projects. Then you can see the whole thing there. I put many different type of projects, and part 3 real case study. Okay, but remember, every one of you have a chance, but you need to set your mind clearly. You can't change the past, but you can change the future by present times. Yeah.
Okay. One more question from me. You said that you include like link in the paper. Is it correct?
Yes. We call the appendix the video. We put the video at the appendix. So
this is the first time I heard that we include link in the paper. Actually,
in fact, if I am a reviewer, I don't trust you. If you don't show me any photo, even a drawing, I think you make up the result. You make up the test setup. Can you show me the video? I completely put this at and then the reviewer will be happy because they can even learn and show to other people. Yes, so remember to put the video in, but don't make your YouTube channel very fancy account. Just put your real name, open publish, and then probably you can be increase the viewer in your YouTube channel as well. Yeah.
Okay, that's a very good idea for me. Yeah.
Yo, please, we have time. Just I'm happy to share, and because I'm alone in India, so. And also the important thing is work as a team and connection is good things. I will say this day, the connection make new friend is important because you're not alone. You not stay here in this world alone. Yeah, and give credit to everyone who helping you. Yeah, you can't go far by your own, but you need to work as a team. This is what I have learned. Yeah.
Yes, thank you. Kalau ada yang mau bertanya dalam bahasa Indonesia juga tidak apa-apa, saya bisa mentranslate ya. I'm afraid one of them want to ask, but cannot speak in English maybe. So I give them opportunity to speak in bahasa Indonesia. Anyone?
I think everyone, probably some of them gone already. Otherwise, we can have a good photo by turning the camera. And I will let you know later, we also have this student mobility program. So that if you want to visit me, and then my Thailand University, of course, we have the program for you. We cover everything. You can have a new friends. Probably your soulmate there. You know, one month or 2-3 months. Yeah.
The schedule, can we get the information about it?
I will give because I put already there. I think in the last of 3.
Okay. how you call him, Mr. Sony or Ahmad Wijaksana?
Sorry,
Mr. Sony or you call it Ahmad Wijaksana?
Sony.
Mr. Sony. She said,
Yeah.
well,
Okay. Hello.
he has something to do, so
I
cannot
see.
join the lecture.
Actually, I would love to visit your university at one day, so we see. Actually, this is the third time that I give the guest lecture and keynote in for Indonesian university. Yeah.
Hopefully, we will manage for that soon.
Yes. Anyone, please? Some of them just put photo, but not checking face. Maybe photo or what? How do advancement in concrete modeling? Oh, this is good question. Modeling, yeah. Right. I also working on the simulations for the impacts. If you, I just published one paper there in building. I use LS Dyna. If you heard about that, and also to do that, we need to get the right consistent model of the whatever material is. So we need to get the right load stress first, and then put that in the models, and then we do some calibrate. I think it's the usual, and we get, and then we can expand to the real model. That's what I did. So I use both Abacus, LS Dyna. Yeah, this is normally program I use. So for impact analysis or really short time, like badminton, I published one paper on badminton. The badminton is the shuttle hit badminton before impact analysis. So you want to see the different type of the string pattern will affect the acceleration and reaction of the player wrist. I use I think LS Dyna for that paper. You can search badminton.
Dyna is the name of the software.
LS Dyna.
Actually, we have one more question. LS Dyna. Previous to the question, seeing increasingly advanced technological development. Would you see it? Before the last question.
Yes, seeing increasingly advanced technological development.
I think the question about how fast the technology in the structural engineering.
Yes, I think in advanced technology development, for example, I would say, for example, in my time, I need to put the strain gauge, and I need to make the cable by itself, and then that's time consuming. But nowadays we have contactless technologies, instruments, and that will save time and also enable you measure things, capture things more precisely. For example, you use DIC, digital image correlation. I just use it. And then the DIC, you know that, yeah? You know this, yeah, DIC. We write our own code using the two GoPro, and then it can capture deformation. For example, low deflection, crack width, crack pattern, without touching the specimen. Because sometimes you can't go very near. For example, the structural that test and suddenly fail. For example, in chair, punching chair, or even impact. For example, I'm planning to do the load bulletproof wall. So I need to go to the soldier army and let them choose. So this one, I use the contactless to see the impact because it's millisecond. Yeah, contactless. So I use DIC, really high resolution of the camera, and to see when the bullet go through the panels, what will happen. So I think nowadays the technology will help us a lot to understand behavior, save our time, but we need to learn those technologies. Sometimes it's many things new coming and I still need to learn. I mean, we call lifelong learning. We need to keep learning. Maybe our students know better than us. Then we come and say, okay, shall we try this way? Shall we try this way? And for example, I built the concrete cutter machine. Eva, you know that I present many times already.
Yes.
If I bought from China, it's very expensive. Then I sit with students. Okay, shall we build our own? Better than you use hammer. And then we build it with do some brainstorming. Then we build it, and this one we help us to publish many paper already. Better than using hammer like our own day. And also, again, advancement in structural modeling. So we need to keep updating the new model, new numerical procedure. And this one, it will help us to understand better the behavior of the concrete structures. Even the concrete structure, steel structure, then it will come back to our design safety factor. If we understand, if we be able to predict more precisely when the structure behave or when the structure fail, then we have more confidence for the design at the engineer. Yeah, maybe that you can see many times that they are trying to develop more precisely model or more precise equation to predict better. But those model may be very complicated and somebody will not use it. Yeah, that sort of thing.
Last question, Arthur. What color?
Again, I think how does the structural engineering research contribute to the development of more sustainable and again this thing again, if we build a new building, I don't think we have any problem because all new code they take account for the earthquakes issues. But again here, as I used to work at the forensic engineer, so we go back to the old structure or substandard structure, let's say, where we have the really bad concrete quality or even the very I mean, not very narrow stirrup or very short spikes, that we have problem when you have the lateral load. So this kind of thing we need to think about the strengthening or reinforcement strengthening work or option.
Like retrofit.
Yeah, retrofitting, yeah, something like that. So again here, this one, if we use some new materials, if we use some advancement, as you say there, structural modeling, it will help us understand better. Because sometimes we can't capture the whole thing. But if we can capture the whole thing and understand the better. So we have the confidence that, okay, we confident this upgrading structure can resist any further incident. That, for example, I also work in terms of fire. Actually, I think even you know that, but I show you later. Fire of the.
Oh yes, last time you share with us in Thailand.
Yeah, the thing is, it seems that I work a lot, but the thing is, we not really have we don't have many very expensive or good quality of the laboratory, but we think and we can build it somehow. But the thing is, we need to get money. But where to get money? That's from the company, from the grant. That's why we are trying hard to get those and build some to facility to make a better ecosystem.
And time's limited, so I think it's okay if we finish this session.
Yeah.
We will have another session. We will discuss about the schedule. So thank you very much, Dr. Imjai. I would like to return the session to the Master of Ceremony.
Thank you to the speaker for the delivery of the material on these occasions today. Hopefully the material present can be useful for all of us. Thank you also to Mrs. Dr. Engineering Insinyur Eva Rivi STMT as the moderator who has quite the material presentation sessions today. As a form of appreciation, all participations are welcome to giving a virtual applause. And the next, we will enter to the documentation sessions. However, before that, I would like to urge today participants to fill in their attendance using the link that has been sent via the chat column. Well, ladies and gentlemen, I would like to invite all participants present to turn on their cameras and use the virtual background that has been provided. Here I will guide the documentation sessions. On the screen, I can see 2 slides. Okay, ladies and gentlemen. I will start from the first slide. I will count until 3. 1, 2, 3. For the next slide, 1, 2, 3. All right, ladies and gentlemen, thank you so much. Thank you for your participations. The documentation sessions has ended. Finally, we have come to the end of the guest lecture Civil Engineering of the Faculty of Engineering Brawijaya University 2023 with theme Structural Engineering Research, Current and Future Challenges. Hopefully what we have live today can be useful for all of us. On behalf of the entire organizing committee, we thank you for your participation and apologize if there are any shortcoming. I'm Helen Heristas, Master of Ceremony at today's event. Said goodbye. Apologize if there are mistakes. Thank you and good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. Shalom, Om Shanti Shanti Om.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Imjai.